All right, so we are going to do a little bit of review on vector addition in a graphical way. So how do we add vectors pictorially or graphically? What can we do? And we're going to look at vector addition mathematically in a lot of detail when we get to two-dimensional motion, when it really becomes critical that we understand how to add vectors. But to have an understanding of the displacement vector that you had in your reading, and to have an understanding of how displacement looks relative to initial and final positions, we want to make sure we understand how to add vectors pictorially. What does it really look like? So this is just going to look at vector addition, and then we'll remind ourselves how to do vector subtraction. Okay, so let's say we have two vectors, vector A, and it has a certain length and a certain magnitude, direction, length and direction. It's represented like that. And then we have vector B. And let's say vector B is represented like that. And we want to look at the resultant vector, the sum of the vectors A plus B. So how does that look pictorially? What does this vector C look like? Now, like your reading suggested, and like we may have talked about in discussion, vectors can be moved all over the place as long as we maintain their length and their direction. So when I want to add two vectors, I always add them from the tail of one vector, connects to the head of the other vector, and we draw the resultant vector from the tail of the first vector to the head of the second vector, or however many vectors that we have. So if I want to add vector A and B together, I can take this vector B, I can move it over here, I can move it over here, I can move it over here. I want to be strategic. I'm going to move it to the head of vector A. So I'm taking the tail of vector B and I'm putting it to the head of vector A. So I pick this up, place it over here, and there is my moved vector B. Then I go from the tail of the first vector to the head of the second vector in a direct line, and this becomes my resultant vector. Vector A plus vector B. So this is our vector C. From the head, the tail of one vector to the head of another vector. So let's just look at that again. We'll pick two more random vectors. Here is our vector A. Here is our vector B. That's not going to be a really good example. I made it way too parallel. Just be difficult to visualize. Let me pick a different vector. Let's do this. There's my vector B. How do I add vector A to vector B? Well, I'm going to take vector B, the tail of vector B, connects to the head of vector A. I shift it over here, move it around as long as I keep the same direction and amplitude. Then from the base of the tail of vector A, I can draw a straight line to the head of vector B to get my resultant vector C. What if I have three vectors that I have to add together? Three different changes in location, positions, to get a full displacement. Well, let's say we move first like this. This is our vector A. Then we move like this. This is our vector B. And then I move like this, vector C. So those are my three displacements, not anywhere in the world, just three different vector displacements that an object moves. What would be the resultant vector? Well, again, I can move them around. I take vector B, the tail of vector B, connected to the head of vector A. Now, I could make a resultant vector and then add vector C to it, or I can just take vector C and shift it, the tail of vector C, to the head of vector B. And I'm going to get rid of this B so that it's out of my way. So there's my vector C, parallel, identical. And then, just like I did with 2, I go from the tail of vector A all the way to the head of vector C. And that becomes my resultant vector. So this resultant was the sum of vector A plus vector B plus vector C. So vector addition, pick up the vector in a pictorial representation, pick up the vector, head to tail, put the tail of the vector, the head of the previous vector, continue that process, and at the end of all the additional vectors, you draw from the tail of the first vector to the head of the last one, and you have your vector addition. Good job.